A set is just a collection of objects, usually numbers or letters or something like that when we're talking about math. An element of a set given by this little symbol is one object in the set. And we'll talk about all these things all these definitions as we go through some of the problems. A well-defined rule determine whether something is an element of the set. Empty or null set looks like that. It's just a little bracket thing without anything in it. Sometimes also to indicate the empty or null set, they do a little circle with a slash through it like that. You've seen that, right? Have you seen that before? That means there's no elements in that set. This symbol means a subset of another set. This little symbol means a proper subset, which means that none of the elements that this subset is actually smaller than the original set, because every set a subset can be every element in the set, but a proper subset is one that is actually smaller than the original set. For example, say I have a set of numbers like 1, 7, 8, and 4. So a subset of this set could be 1, 7, 8. 1, 7, 8, and 4. Okay, but that would not be a proper subset. In order for it to be a proper subset, it actually has to have just like less elements than this one does. So a subset, this could be a subset of this set, but in order for it to be a proper subset, it would have to be missing one of the elements. So that would be a proper subset, like 1, 7, and 4 or something. Okay. Universal set is a set containing all elements of the things you're talking about. When you see a little bar on top of it, that's called the complement, and that's all the items in a set that are in the universal set that are not in A. We'll talk about that. We'll talk about Venn diagrams. We'll talk about disjoint sets, finite sets, and so on and so forth. So for instance, write these set possible results from tossing a coin twice. What could happen if you toss a coin twice? What are all the possibilities? You could have a heads and then a tails. What else could you have? You could have heads, heads. You could have heads. No, you couldn't. You could have tails, heads, or you could have tails, tails. So you'll see that we talked about that's a tail. Tail, tail. So that's a set of possible outcomes if you toss a coin twice. Are there any others? I don't think so. Write all these subsets of the set A, B, and C. Okay? So if I were to do that, and the way I would do that is so you have one set. I don't like this color. One set would actually be A, B, C. I'm not very good at drawing these little bracket things. Another one would be A and B. Another one would be A and C. Another one would be B and C. There's more. Another one would be, give me another subset of that set. A. A just by itself is a set. B is a set. Okay? Whoops, I shouldn't have a comma there. Mark. B is a subset. That should be a squiggly thing there. to write from this perspective. C would be a subset. There's one more. 1, 2, 3, 4, 5, 6, 7. Anyone know what the other subset is? Huh? Yeah, just the blank. The null set or the empty set. So another one is like that. So it turns out that if you have 3 items in a set, well, that this rule comes up later. But if there's 3 items to a set, there would be 2 to the 3rd subsets of that set. So if you have 4 items in a set, there would be 2 to the 4th numbers of subsets. Okay? And if you have 5 items, there would be 2 to the 5th subsets. Okay? So find each intersection, draw a Venn diagram. Do you guys know what a Venn diagram is? They're those little circly things. Ooh, I could use my circle tool. Where's my circle tool? So Venn diagrams look like, that's not a very good Venn diagram. It should be in the box. Oh, this is, let me, that's bad. Let me grab this guy. Let's draw one here. There, that's a little better. Okay. So anyway, a Venn diagram with that is the intersection of A. This means intersection, this little thing. Okay? So Venn diagram represents the set. So you have 1, 3, 5, 8. 1, 3, 5 have to be in here, right? 8 is over here. And in this one we have 3, 5, and 7. So the intersection of that set is right in here in the in between. Yes? You get that? So this upside down thing means intersection, okay? Meaning what those are items that are contained in both sets. Okay? That's what an intersection is, okay? U, which means union, is anything that is either or in both sets. So if I wanted to do the union, A union B, okay, that would look like, let's see if I could draw my circles better this time. Okay? Probably not. Is this going to draw circles? I don't want that. I want this. Let's see. Maybe if I start up here. Gosh, I'm bad at this. I'm going to do this right. I'm going to take this circle. I can move it down. Can I move it down? There. There's a circle. Let's do another circle. This thing is...
That is a big circle.
Oh, you tell me. I'm a professional. Oh, now I'm drawing circles all over the place. Wait. I need to grab this circle. There. And move it there. Ooh. Okay. So now, if I wanted to do A union B, okay, it looks just like this, except it's all items that are in either set. So it's 1, 8, sorry, squiggly thing. 1, 8, 3, 5, and 7. But the union is all of those. So if I shape the entire area, okay, this represents the union of A and B. Okay? Can't see this. It's anything that's in either or. Okay?
So just everything?
Everything that's in either this set or that set. Okay? So if I wanted to do B intersection A union C, on here I have to draw circles again. What? Am I in the way? Sorry. Okay. So if I want to do, that's the problem with this. I'm always in someone's way. Okay? And it kicks me when it gets so it's okay. So if I want to do A union C with the intersection of B, I draw a circle, and then we'll just draw another circle, and then I'll try to move them around. Now I can move them around. So if first you do A union C. So has 1, 3, 5, 8, and the only thing they have in common, it appears, is 8, right? So I'm going to get a different color because that's kind of hard to see. So A8 goes here, and then 1, 3, and 5 are floating around out here, and 2, 4, 6, 2, 4, 6 are floating around out here, right? So if this is A, and this is C, and then B is 3, 5, 7. So B is, how do I do that? 3, 5, so B would just be like, is there, so B, if I did that, would just contain 3 and 5, and then 7 out here. So if the union of A and C, let's use a different color for this too. If the union of A and C is here, right? And the intersection of that with B would be right in here. Do you guys see that? That would be the intersection of B with A union C. So that would be what numbers would be in that set? Just these two, 3 and 5. See that? Okay. So that would be 3 and 5. Like that. So these should have answers too. This would be 1A 3, 5, 7, right? 1, usually you want to arrange them numerically too. 3, that's a 3. 3, 5, 7, 8. Very sloppy. And this over here would just be 3 and 5. Okay? You get that? Is that hard? It's not that hard. Right? Okay. So the next thing is find all the elements. So what this says is find all the elements that are, this is called the universal set. So these are all the items that are, this is called the complement, that are in the universal set but are not in A. So who can tell me what those are? Hello?
2, 4, 6.
Right, it'll be all the even numbers, I think, right? 2, 4, 6, 8. Just those even numbers, not all the even numbers, right? Because that's a finite set. The number of subsets of A,
32.
it would be, you could list them all, but you don't really want to do that. It's just 2 raised to the 1, 2, 3, 4, 5th power. So that would be 32 subsets. You don't want to list those all. That's a whole lot. Okay? So that's what that formula gives you.
Wait, why 2?
Why is it 2? It's what? There's no 2, because if I go back to this, it's just the way it works out, this formula. The number of sets, if A is a set with n elements, then A has 2 to the n subsets. Okay? So just the way the math works, I guess. Okay. And then so in a survey of 100 college students, 35 were registered in college algebra. This is a classic ACT problem. Okay? In a survey of 100 college students, 35 were registered in college algebra, 52 were registered in computer science, 18 were registered in both courses. How many students were registered in college algebra or computer science, et cetera, et cetera. So the best way really to do this is with a Venn diagram. So if you were to draw a circle here, and another circle here, and see if I could drag them around, make them overlap. This one should fit inside the box. Make it small. something like that. Okay, so 35, so we'll call this college algebra over here, and we'll call this computer science over here. And then it says 18 were registered in both. So you could actually put the numbers. There's 18 kids in here. See that? Okay? How many kids have to go out here? Students, sorry. If this is computer science, 52. No, altogether this circle has to add up to 52, right? So how many go out here? 52 minus, so there's 37 in that part of the circle. How many in this part of the circle over here? There were 35 students in college algebra, so how many over here?
It's 34.
Huh? What? 55? No, it says that's a 35, right?
It's 34 in the computer science, not 37.
What?
52 minus.
Oh, this is wrong. Sorry. That should be 34. You're right. What should be sorry. Thank you, Ra. 17 over here. Everyone see where I got 17? 35 minus 18. Okay. So it says how many students were registered in college algebra or computer science 1? Altogether, how many students were registered? 35 plus 52 makes how much?
Oh, that's wrong.
That's wrong. That's right, Antoine. Why is it wrong? Because why? What about these kids here? How many times am I counting those when I do that? Twice. So I need to subtract 18. See that? Okay. And so that number is that 69 students? Yeah. Okay. So the answer to that is 69 students. How many were registered in neither course? If there are 100 altogether. Right? So there's 100 in this box, right? So if I subtract my 69 minus 100, I get that there's got to be 31 floating around out here, right? See that? Okay? And that's what this formula says, okay? If A and B are finite sets, the number in A union B is a number in A plus the number in B minus the intersection. That's basically what we just did right here, okay? So it's a number in set A plus the number in set B minus the number at the intersection of A and B, because you're counting those guys twice. And this one says that the intersection, if there is no intersection, then all you have to do is add up the number in A and the number in B. Okay? And I think that this one, I think you could figure out just by looking at it, okay? As of June 2002, federal employee, blah, blah, blah. The table lists the kind of law enforcement, no officer is classified as more than one type of officer. How many full-time law enforcement officers or criminal officers or correction officers? Hello, what do I do with that? Criminal officers or correction officers, how do I figure that out? Just add this number plus this number. And then it says how many full-time law enforcement officers in the U.S. federal government were criminal officers, correctional, or non-criminal. So you just add this plus this